Good afternoon, everyone. I'll be sharing the screen now. Okay, so let's begin our session. In the previous session, we discussed about roots, nature of roots, and common roots. Today we will be discussing about graphs of quadratic equation them. Okay, so before that, let's do a recall test. All right. So what is the product of the roots of this equation? All right. So here it is given to us that 90 square minus 18t plus 5. So here what we have done is we have we have assumed t to be mod x, right? And then we got two values mod x equals to 5 by 3 and 1 by 3. So since mod x is 5 by 3, x can be plus minus 5 by 3, and since mod x is 1 by 3, x can be plus minus 1 by 3. And when you multiply all these four roots, you get 5 square into 1 square upon 3 square into 3 square, right? So this comes out to be 25 by 81, right? So this is our answer, 25 by 81. Okay, I hope the recall test was easy for you guys to understand. Let's move on to the next slide. Okay, now for graphs of quadratic equation. So we do consider first graph of y equals to x square. Okay, so y equals to x square. Here y equals to x square is given to us. Now here if you compare this to ax square plus bx plus c, then you know that the value of a is 1, b is 0, and c is 0, right? So f of x is equals to x square, right? So f of 0 will be, and since it is x square, we can say that x minus 0 whole square is 0. That means 0 is the repeated root. So whenever the graph is repeating, it like has a repeated root at a particular value, this is our 0 comma 0. So the graph will pass through origin like this and like, right? So this is how our graph of y equals to x square looks like. So to draw the graph, for roots, all right, you need to know the vertex, you need to know the roots, and then I think you can draw the graph, right? And you should know whether it will be upward or downward. So for drawing the graphs, these all parameters are essential and helpful. Please note down that these three parameters, if you know, then you can draw any graph easily for quadratic equation, right? So let us try to understand the graph of y equals to x square plus 1, right? So for this thing, can I write y minus 1 is equals to x square, right? So when I put x equals to 0, you get y equals to 1, right? So you know that this graph has a vertex at x equals to 0. To find the vertex, location of vertex, how can you find the location of vertex? To find the vertex, you can do, there is a trick, right? You shift all the y terms here and make here in terms of square, right? And here y, right? So then you get to, you then equate both the sides to 0, then you get the vertex. Whatever is there in square you equate to 0, and whatever is there on the left side you equate to 0. So here, from here we can know that y equals to 1 and x equals to 0 is the vertex. So you can see here that this graph here is passing through y equals to 0 comma 1, and it is passing such that it is touching this line, right? So 1 is the repeated, sorry, this line is passing by touching this line, and this is above the x-axis, so that means there are no real roots. Okay, and also to find the vertex, what we can do is, okay, to find the vertex, see, we all know that the vertex can be found out by doing this. You guys, do you guys know, remember that ax square plus bx plus c equals to 0? This was our f of x, right? Or y, you can say, correct? So this was our y. So what I can do is y plus b by 2a equals to a times of, sorry, this was d by 4a. Y plus d by 4a was a times of x plus b by 2a whole square plus something over here, right? So from here we found out when you equate to 0, you get to know x is minus b by 2a and y is minus d by 4a. So this is the vertex. So for y equals to x square minus b is 0, right? So that is why the vertex is 0 x coordinate, and y coordinate d value b square minus 4ac, b is 0, c is 0. So this also comes out to be 0. So vertex is 0 comma 0. For this value, if you put minus b by 2a here, you know that b is 0. So x coordinate is 0 comma y coordinate minus d by 4a. So b square minus 4ac is equals to 0 minus 4 into minus 1 into 1 upon 4a, which is 4 into 1. So this will come out to be 1. So 0 comma 1, 0 comma 1 is the vertex for this thing. So this graph 0 comma 1, this graph, this y equals to x square minus 1, and this is touching the 0 comma 0. So this graph is for y equals to x square. This graph is touching at 0 comma minus 1. This graph is for y equals to x square plus 1, right? And by general understanding of graphs, we can say, see, when you add, when you do plus 1, the graph will shift below. When you do minus 1, the graph will shift above, because for that same particular, like x value, you get y plus 1, right? When you do minus 1 with the x square, so for that same x you are getting one more y. So that is why when you subtract a constant y equals to x square minus c, then the graph moves c units upward, and when you add the constant y equals to x square plus c, the graph moves c units downwards, the entire graph. Okay, so y equals to x plus 1 whole square. So this graph is very easy. Y equals to x square was a graph. Now y equals to x plus 1 whole square is a graph. So whatever value of y you were getting for this x, now you will get for one more x. So that is why when you add a constant here, the graph will shift to the left, right? This is the graph of y equals to x plus 1 whole square. This is the graph of y equals to x plus 1 whole square, right? This is the graph of y equals to x square, and this is the graph of y equals to x minus 1 whole square, right? So this is how you can understand, this is how you can understand that how these three graphs change, or how any quadratic equation will change when a normal constant is added, right? When a normal constant is added and when a constant is added to the x variable and increased or decreased. So these are the two differences. Okay. So now when you multiply, see f of x is given as, consider this is our f of x is x square. So now f of x became our 2 times of x square, right? So the graph will shrink, right? How you can say, see, for in this thing, for 0 you getting 0, for 1 you are getting y, f of x for 1 you are getting, when x is 1 then y is 1, when x is 2 y is 4, right? But for over here, when x is 1 y is 2, when x is 2 y is 8, right? So it is getting higher value for lower x's. So that means this is the graph, this is the graph of y equals to 2x square. This is the graph of y equals to x square. This is the graph of y equals to 1 by 2 x square, right? So whenever the graph is multiplied, like whenever you multiply a constant greater than 1, the graph shrinks. And whenever you divide a constant greater than 1, the graph expands, right? This graph has expanded here and shrinked here. So this is how you can understand. Now y equals to x square and minus x square are, y equals to x square and minus x square are mirror images about the x axis, right? As you can see here. Now in this scenario, how will the graph look like? So there are, see here the vertex is y1, x1 comma y1. The vertex is x1 comma y1. So x1 comma y1 can be anywhere, right? And k can be anything. K can be positive, k can be negative. X1 comma y1 has 4 options, which are 4 quadrants. So based on k and x1 comma y1, we can determine the graph of a quadratic equation. Now, how to determine the graph of quadratic equation? See here, this we had already written, right? Y plus d by 4a is equals to a times x plus b by 4a whole square. This is equals to this itself, right? This thing has been, if you apply the completing whole square method, then you get this equation, sorry, this equation, right? From here, you can say that the vertex of the graph is x coordinate. X coordinate is minus b by 2a and y coordinate is minus 4a. We just have to equate this to 0 and this to 0, right? So this is our vertex, correct? Now Now when A is positive, here as you can see that alpha beta is positive, A is positive, it is considered positive. Whenever A is positive, you get upward parabola. So I'll just take a slide to explain things. Whenever A is positive, you get upward parabola, and f of 0, whenever you substitute x as 0, you get the value c, right? So 0 comma c, wherever the graph cuts the y-axis, for x equals to 0, right? Functional value for x equals to 0. Now how do we differentiate the graphs, right? Example, f of x equals to ax square plus bx plus c when a is greater than 0, b is less than 0, and c is less than 0, right? So from here a is greater than 0. See, this is upward parabola, right? Upward. This is upward. This is also upward. This is downward. So how do we analyze these graphs? Okay, wherever you see a question about graphs or something that can be solved graphically, at that time, how do you analyze those graphs? So what we will do here is, see, this is a vertex, right? This is minus b by 2a, comma minus d by 4a. Here it is clear that y is 0, right? Since it is touching the x-axis, so that means minus d by 4a is 0. So that means discriminant is 0. That means the roots are repeating itself. So you can say that as well. Now minus b by 2a, minus b by 2a for this graph is x coordinate of this graph. See, this is lying on the right side of the y-axis. So the x coordinate is positive, right? Minus b by 2a is positive. And since it is upward parabola, a is positive. So when a is positive, to make this whole positive, b should be negative, right? Correct. So from here, I can say that b is negative. Correct. And so f of 0 is c, right? F of 0 is c. This is 0 comma c. Now this constant c is lying above the x-axis. So here I can say c is positive. So these are all the three signs that we can interpret. Similarly, you can solve for this graph also. Here f of 0 is c, so c is positive. Upward parabola, so a is positive. Now minus b by 2a, x coordinate is again positive. So that means b is negative, right? So here it should be, this should be less than 0 or c is greater than 0, correct? Now here in this graph, you can see that if you extend the graph, this will cut the y-axis above the x-axis, right? So here c is positive again. Here since minus b by 2a is on the right side of the y-axis, b will be negative again, and upward parabola, so a will be positive, right? So these are the three things in all these three types of graph. Similarly, here there will be some other case. A is negative, minus b by 2a is still on the right side, so b is also negative. Now c is negative because if you extend the graph, it will cut the y-axis below the x-axis, correct? So this is how you analyze the signs of a, b and c. Now here signs of quadratic equation, right? Quadratic equation. Here consider this root alpha and consider this root as beta, right? Here it is like alpha comma beta, whatever you say, alpha beta. Let's say it is alpha. Whenever the graph is lying above the x-axis, then then the f of x, which is the quadratic equation, is positive, right? Here also f of x is positive. Now whenever the graph lies below the x-axis, so this means that f of x is negative, correct? So for this scenario, can I say that if x is element of minus infinity to alpha, union beta to infinity, then f of x is greater than 0, right? And if x is element of alpha to beta, then f of x is less than 0, correct? And similarly for this thing, you can see that the graph is never going below the x-axis, right? It is never going below the x-axis. So for this thing, for this graph, second scenario, what we can say here is that f of x is greater than equal to 0 for all element of for all x element of real numbers, correct? So this graph is going to become 0 at one point, which is the repeating root, and it will always go upwards. So that is why this graph, the sign of this graph will be always greater than equal to 0. Now for this graph, okay. So now in these two conditions, in these first and second condition, can I say that discriminant is positive in the first condition? Because there are two distinct roots, right? And in the second condition, can I say discriminant is 0 because the root is repeating? And in the third condition, can I say discriminant is less than 0 because the graph is not cutting the x-axis or touching the x-axis at any point. So for this thing, I can say f of x is always greater than 0 for all x element of R, right? So whenever the question comes about the quadratic equation and it says that this equation is always positive, so the only case where it can be positive is first case, a should be greater than 0, okay? Because if it is a downward parabola, some point it will become negative, right? So therefore a should be greater than 0, condition compulsory case. And second thing is d should be less than 0, right? If d is not less than 0, then touches the x-axis or goes below the x-axis. So this is the condition for strictly positive graph or function. Now this is the condition for non-negative graph slash function, right? So what is the condition for being non-negative? A should be positive and D should be greater than equals to 0. The only difference is D, only difference is here, equal to sign in the discriminant, right? And the inequality sign, correct? Okay. Now moving ahead, let's try to solve a question. If the quadratic expression x square plus 2ax minus 3a plus 10 is greater than 0 for all x element of R, then, right? So just now we understood when can this be a possible case? When first thing, when our a is greater than 0 and when d is always negative. So first condition we will check a is equals to 1, which is satisfied. Now for d less than 0, we'll try to solve. What is d? D is 2a square minus 4 into a into c is minus 3a plus 10. This should be less than 0, right? So this becomes 4a square minus 4 times into minus 3a plus 10, minus 3a plus 10 less than 0. So 4 gets cancelled. This becomes a square minus plus 3a and plus minus 10, right? This is Now if you split this will be a plus 5 into a minus 2 is less than 0. So now we know that this is only possible for a element of 2 to, sorry, minus 5. A is element of minus 5 to 2. So can I write a is greater than minus 5 and less than 2? Correct. So our answer is option C. Now case 2 for downward parabola. So the analysis that we did in the upward parabola is similar to this analysis that we are going to do here, right? So here you can see the graph is upwards. Like this graph is actually a downward parabola, but it is upside the x-axis when x is lying between alpha to beta, and when x goes beyond beta and beyond alpha, then the graph is falling down of the x-axis. So this means that my if x is element of alpha to beta, then f of x is greater than 0, right? And if x is element of minus infinity to alpha union beta to infinity, f of x is less than 0, correct? So this is for this graph where a is less than 0, and whenever a is less than 0, here since there are two distinct roots you can see in the graph cutting the x-axis, that means d is greater than 0. Okay, so for this graph the conditions are a is less than 0, d is greater than 0, and this is the range of, sorry, this is where it is positive and where it is negative. Here you can see that for all values of x the graph is going below the x-axis, and there is only one x when it is touching the x-axis. Let's call this the root alpha. Okay, so for this graph, can I say that f of x is less than equals to 0 for all x element of R? And for this graph we can say that a is negative since it is a downward parabola, and discriminant is equal to 0, right? Discriminant is equal to 0 since the root is repeating itself. Now in the third condition you can see the graph is always below the x-axis. So this means that f of x is always negative, right, for all x element of R. Now in this condition I can also say that a is negative since it is a downward parabola, and d is also negative since there are no roots because it is not cutting the x-axis, right? So whenever the graph is always negative, this is the condition to follow, and whenever the graph is non-positive, okay, this is strictly negative, correct? So remember these two conditions. Now range of quadratic equation, right? So to find, see, I'll give you a trick. Okay, so let's say f of x is a quadratic equation q1, or let's say f of x is a quadratic equation q1 plus q2, or let's say f of x is q1 by q2, okay, or f of x is 1 by q1. So in all these condition, take down this step. First of all, equate y equals to q1, y equals to q1 by q2, y equals to 1 by q1. Okay, now second step is take y with the quadratic equation on the same side, okay, treating y as a constant. Now third step is use discriminant greater than equals to 0. So whatever you get the values of y, it will give you range. Correct? Now let's see for an example. See, if I want to find out the range of a simple quadratic equation x square minus 5x plus 6, right? So you know that this graph has 2 and 3 as its roots, right? So what I'll do is I'll draw 2, I'll draw 3. I know that the vertex is the minimum value for this, and the maximum value for this is the graph will go infinity, right? Maximum is infinity and minimum value is at the vertex, which is minus b by 2a minus d by 4a, right? So for simple y equals to q1, you can simply find the find the vertex, right? Vertex. So the value of y, the value of y at vertex is maximum for downward parabola, and is minimum for upward parabola, right? Upward parabola goes to infinity, downward parabola goes till minus infinity. So for simple quadratic equation, this is the best method to do. Find the vertex, correct? The y coordinate of the vertex. And for the type of equations or expressions where you get like this 16x square minus 12x plus 9 upon 16x square minus 12x minus 9. So in this thing, what I can do is I can treat this, I can do x square y minus 12xy minus 9y equals to 16x square minus 12x plus 9, right? Now I will take this 16x square there, that will become 16x square y minus 1 minus 12x y minus 9 y plus 1 equals to 0. So here what I will do is I will do discriminant greater than equal to 0. So now I will treat this as a quadratic equation in terms of x, and y minus 1 will be our constant, constant, right? This will be again constant. So for d greater than equals to 0, the coefficient of x is 12 times of y minus 1 whole square. Okay, b square minus 4 into a is 16 times y minus 1, c is minus 9 times y plus 1. This should be greater than equals to 0. So as you can see that this becomes 144 y minus 1 whole square minus 4 times 16 nines is 144. This becomes plus, and y minus 1 into y plus 1 will become y square minus 1 greater than equals to 0. 144 gets cancelled. This will become y minus 1 whole square plus 4y square minus 4 greater than equals to 0. And when you solve this, you get values of y which will be the range of given expression, right? So in this manner, okay, in this manner you can find out about the range of any quadratic equation or an expression which has quadratic equations in it, correct? Which has quadratic polynomials involved, right? Okay guys, so I think our time is up. So I hope you understood today's session. Have a good day, take care, bye bye. Thank you guys, thank you for attending the class. This is the this is the homework. If you want to do this homework, take the screenshot and try to solve these questions. Mostly it is related to first and second session. All right, guys. Have a good day. Bye bye.